Hi everyone, welcome to another video on index numbers. So our main focus today will be on the weighted aggregative method. So what is the weighted aggregative method? This method is the same as a simple aggregative method, with the only difference that weights are assigned to the various items included in the index. So symbolically, it is the summation of the current year prices and the base year divided by the base year price. But here we are saying that the only difference is that weight are now assigned to the various items. So here we attach a weight to it, then you multiply by 100. Why do we attach weight to it? Now let's find out. In index number calculations, not all items are treated equally. Some commodities have greater impact on the overall index because they are produced or consumed in larger quantities. For example, if rice is consumed more than millet in a country, then changes in price of rice will have a bigger influence on the price index than changes in the price of millet. This is why weight are often assigned based on quantity produced, sold, or consumed, so that more important items have a greater effect on the index. We therefore use the quantities in the base year or given year or the average of several years as weights. There are various formula of assigning weight to an index. The more important ones are as follows. The first one we are going to look at is the Laspers formula. And the Laspers formula uses the base year's price or the base year what quantity as weight. So let's take note that the Laspers uses the base year price or the base year quantity as weight. So this weight here, based on which one we are going to, whether you are using whether you are calculating for the Laspers price or the Laspers quantity. If it is Laspers price, then mean that the quantity will serve as the weight. And if it is Laspers quantity, meaning that the price will serve as weight. Now let's take them one after the other. So with the Laspers price index, so it uses base year quantities as weight to measure the change in the total cost of a fixed basket of goods over time. So the Laspers index may overstate inflation because it does not account for consumers switching to cheaper substitute when price arise. And this is termed as the what? Substitution bias. That's the what? Substitution bias. It doesn't account for consumers switching to what? Cheaper substitute when price of the commodity rises. So, and it is given by, because we are it uses the what? The base year price or quantity, and here we are looking at price. So meaning that the quantity is going to remain what? Fixed, which will also serve as the what? Weight. So the Laspers price index is given by sigma of current year prices times base year quantities divided by summation of base year prices and base year quantities times 100. Now let's take the Laspers quantity index. The Laspers quantity index is used to measure the change in the physical quantity of goods and services over time. using base year prices as weight. So whereas the price uses the quantity as the base year quantities as weight, here it uses the base year prices as weight. It tells us how much of the total output or consumption has changed in terms of quantity. Because looking at this one, we are making the price constant. So these ones are the one, or the quantities are the one varying. So basically, it tells us how much output has changed in terms of what quantity. And this one tells us how prices are changing with the first basket of what goods. It may not fully capture shift in price sensitivity, but it is useful for analyzing production or output goods. So for the last place quantity index, because prices are constant, it becomes sigma of current year quantity times the base year prices divided by sigma of base year quantities and base year prices. Another formula is the purchase formula. Purchase formula. So the purchase formula uses the current year quantities or prices as weight. Let's take note. The last place uses the what? The base year quantities or price as weight. Whereas the purchase, it uses the current year quantities or the current year prices as weight. We also have two. We also have the purchase price and the purchase quantity index. So for purchase price index, it measures the change in the cost of purchasing a current year basket of goods and services at current prices compared to the same basket price at the base year prices. It uses current year quantities as weight. Purchase index reflects consumer substitution since it uses current year quantities. So when you look at the formula, you have the current year prices, current year quantities. So it what? It reflects consumer substitution since you are using current year quantities as what? As the weight. Or divided by the what? By prices in the base year times current year quantities, or multiplied by 100. Also, when you come to the quantity index, that's the purchase quantity index, we use the current year prices as weight. So it measures the change in quantities of goods and services over time using current year prices as weight. It compares the current year quantities to the base year quantities while keeping price level constant at the current year level. It's also given by summation of current year quantity and current year prices divided by summation of base year quantity and current year prices multiplied by 100. Another aggregative method we are going to consider is the Fisher's ideal formula. This formula is the geometric mean of the last pairs formula and the purchase formula. Fisher's ideal index is called ideal because it combines the strength of both the last pairs and the purchase formula. It neutralizes the upward bias of the last pairs index. That's we stated that last pairs tends to overstate the values, and the purchase tends to understate the values, and the downward bias of purchase index to a great extent. In fact, Fisher's ideal index is free from any bias. So we also have the Fisher's ideal price index, which uses the geometric mean of the last place price index and the purchase price index. So for Fisher's price index is equal to the geometric mean of the last place price index times the purchase price index. For Fisher's quantity index, it is the geometric mean of the last place quantity index multiplied by purchase quantity index. Okay, let's take an illustration and apply all the three methods or the aggregative methods. So illustration, using last place price and quantity, purchase price and quantity, and Fisher's ideal formula, that's both price and quantity. Find the index number from the following data. Find the index number from the following data. So we have commodity A, B, C. We have their prices in the base year, prices in the current year. Then we have the quantities in the base year and quantities in the current year. Let's dive into solving it. So now let's pick the last place price and quantity. So before then, let's create a table. So we have commodity to simplify the calculation. We have commodity A, B, and C. Then we have prices in the base year. So let's say price in the base year is P naught, price in the base year. Then this one, prices in the current year. We have 4, 3, and 2. Then this one is given 10, 8, and 4. Then this one is the units, so quantities. So quantities in the base year, then quantities in the current year. 50, 10, and 5. Then for quantities in the current year, we have 40, 8, and 4. Let me bring another column here that comes out total. So for last place, price index is equal to, since last place uses the base year quantity or price, and we are dealing with price, so meaning that you're going to use the base year quantity as what? As weight. So we have price and quantity, price and quantity. Okay, so per the table here, we have to find the summation of current year prices and base year quantities. So let me create another column, prices times base year quantity. Another thing we will also need is base year prices and current base year quantity. Base year prices and base year quantity. So for the first commodity, that's commodity A. For commodity A, the current year prices for commodity A is 10, and the base year quantity for commodity A is 50. So 10 by 50, 500. Then 8 by 10, 80. 4 by 5, also giving us 20. Now we need to find the summation. So here's sigma, summation of 500 and 100, 600. Now we need to find the summation of base year prices and base year quantities. So base year prices 4 and 50 for quantity A, giving us 200. Then 3 and 10, 30. We have 2 and 5. Can say 240. Now let's find for the last best price index for the current year, because you know that for base year it's always 100. So for the current year, let me write here, for the current year is equal to 600 divided by 240 times 100. $250. Now let's find the last best quantity. Last best quantity index, also given by so one trick you should note here is last best quantity, last best quantity. Quantity is the main thing, so quantity is varying. And you know that last best uses base year price or quantity. So if quantity is varying, meaning that the prices are going to be used as weight. So we use the base year prices as the weight. So looking at this formula, we've already found the denominator, that's this and this, to be 240, but we don't have base year prices and current year quantity. So we have to create another column for base year prices and current year quantity. Base year prices and current year quantity. So where are the base year prices? So we have it here, and the current year quantity. So the first one is 4 by 40, 160. We also have 3 and 8, 24. Yeah, 24. Then we have 2 and 4. 2 by 4 is giving us 8. So now we have to find the summation, which is 160 plus 24 plus 8, 192. Now let's find the last best quantity, which is 192 divided by summation of the base year price and base year quantity was 240 times 100. 192 divided by 240 times 100, 80. So we are done with the last space. Now let's come to the purchase. So now we have the purchase price index. It's also given by So for Pache, it uses the current year quantity as the weight, the current year quantity as the weight. So based on this formula, meaning that you have to find the summation of the current year prices and current year quantity. So let me create another one. Current year prices, current year quantity. Also, there's one thing we have to find. Base year prices and current year quantity. Let's see whether we have it. Base year prices and current year quantity. So there's no need for us to create another column again. We just have to put the total there. So now let's go ahead to find the current year prices times the current year quantities. So current year prices, we have 10 and 40, which is giving us 400 for the first commodity. That's 10 and 400. Then the next one is 8 and 8. That's 8 and 8, 64. And also the last one is 4 and 4, which is 16. Go ahead to find the summation. 400 plus 64 plus 16. 480. Now let's find the Pache price index. 480 divided by base year prices and current year quantity. It was 192 times 100. 480 divided by 192 times 100. 250. Okay, now let's find the purchase quantity index. And the purchase quantity index is given by so we already have this for which we've done up here. That's 480 base year prices multiplied by base year quantity. 480 divided by current year prices and base year quantity. Current year prices and base year quantity. Summation of 600 times 100. Also having 80. Good. So now you can go ahead to find the Fisher Price index, which is given by the geometric mean of the last place price index times the Pache price index. So for last place price index, we had 250, and Pache we also had 250. So the answer will be 250. So this is giving us 250 for the Fisher's price index, 250. When you come to the fish's quantity index, it's also given by the geometric mean of the last best quantity index times purchase quantity index. 80 by 80 equals 80. Alright, so now this one, even though we are getting the same thing, we will solve another example where we can easily make the comparison. You can easily check whether the last space and overstate inflation. You will check that and prove that. Other than that, we are done solving this illustration.